good late morning. And topic of standards and interoperability and so on. And we've heard a lot about that over the past couple of years, mainly promises, right? So we all think, yes, data is key. We've seen that as the first slide in every presentation. I also have a slide like that, so I won't disappoint you. The thing is, yes, people have these ideas of what they can achieve once they have all of their data. But then the question is, okay, how do I then represent my data adequately so I can get value out of it? And obviously standardization in terms of data formats, communication protocols, and so on, were seen as contributors to those types of initiatives. Now, there's been a lot going on and many things happening, and now we are seeing the fruits of the labor. And the idea here is to, on the one hand, present the view on how standards can fit into such an ecosystem within the company, but also to look at what is the ecosystem that is already out there in terms of coverage and support that we can leverage today. Because in the end, when we roll something out, we can't deploy a PowerPoint presentation to suddenly generate value, right? And we need to get, transition from PowerPoint to sort of real life, and that is a hard problem. So here is a little bit of how we sort of see this thing fit. And so as you may have noticed, BSSN software is now part of Merck Life Science. And this is helping us as an organization to sort of take the next level in terms of scaling the offering to a global perspective. We're very excited about that journey. And also as Heiner, my colleague from Merck, presented this morning, we are very much thinking about what we can do with data. And obviously what we are doing at BSSN software is the customer-facing bit. We're not a Merck internal IT organization. That is where Heiner, obviously, is the expert. So if you want to talk about that, you should talk to Heiner. So, and here it is, right? Obviously, here's the promise slide that data is an asset, and it's so important. And is there anyone who disagrees? Can we see a show of hands? Wonderful. So we can take that as a conclusion. And Daniela, maybe for the record, right? Data is an asset. I think we can. Good. Yeah. Wonderful. But if we drill into that, what does that mean? There are a couple of things. So I believe it's not just about the data, it's about the accessibility of the data. Because just having it is not enough. Not only do I need to have it, I need to give that to the people who can generate value out of it. And there is a bit of a disconnect, right? We are doing a lot of things to collect and to, we're all hunters and we catch and so on. We put those into our beautiful data lakes and repositories and we annotate it and all of it. But then can we give it into the hands of an average user so that he can do his job better, or so that we can learn from the things that we've done as an organization in the past? If we manage to do that, then we are really leveraging the value of data. Yeah, and then obviously this phrase, data is the most important result of work in the lab, becomes much, much more meaningful. Because that is basically transactional data that we are generating with every experiment. That transactional data provides value if it's properly contextualized and if I make it accessible and findable. Now, what can I do then? I can then integrate between systems. I can collaborate with partners inside and outside my organization. I can do data analytics. And I can keep it around. And those are all very helpful things. So a not-so-famous person said that the hypothesis is that the more accessible we make our data, the more it will be used. It's a fairly simple statement, right? And there, again, it's not just about having the data, but if I make it available for an average user to consume and do his job better, then I generate value. So, yes, we all agree, I think, there's the relevance of data and all of that. But where do we stand? And how can we identify what we need to do? And there are two things that that help us look at that. On the one hand, there is a technology play. What are the systems and the capabilities that we need to provide within an organization to enable that? But also, how do we need to change our processes and our culture to enable the generation of that data? Because if we don't do that, then obviously there is not much that we can leverage. So for that, we have a capability maturity model that helps us assess where we stand as an organization in terms of those lab data management capabilities. And it all starts with making the data uniform. So as a baseline, I am able to aggregate. So the question that we then ask is, are we able to bring our analytical and biological data into one common format? If we manage to do that, then that opens the door to many ways of leveraging that data. We can obviously look at it from the perspective, oh yeah, we'll just throw everything into a lake and then worry about getting it out later. So we defer the problem to the time of query. We believe that it's the wiser approach to do that at time of ingestion, because that's when I still have all of the information available. And that's why my vendor is still willing and able to help me and so on. If I then try to do that 5 years down the road, and then I have this ugly lake of trash, then yes, I have the data, but there's not much I can do with it. So it starts at the time of ingestion, as I pull my data in. And there the question is, how can I normalize it at that point? So that's where we also started. Now the question is always, yes, we can talk about capability, but we also need to talk about the value that that capability generates. Now the data normalization itself is not generating value. If you talk to a scientist, you can say, hey, now we've got everything in this common format X, whatever it is. And the scientist is going to say, cool. It's like having money. You can't eat it. It's still useful, but you cannot eat it. You can turn that into something useful by buying food also. And it's the same thing with data. So the normalization is the first bit. Then the question is, how do I deliver value? And then I ask my scientist, because he knows. And he will tell me, well, suddenly you have the data of all of your analytical techniques in one format. Cool, give me a way of looking at it. And then I will agree that I have value. So with this approach, what we can suddenly do is we can build a single tool that works across measurement techniques, that works across vendors. That is then only possible because we were able to normalize the data in the first place. What we did was we took it a step further. We thought this also should work across platforms and devices. So whether it's on a mobile device, as a web app, or as a desktop app or so. Those are then the things that we've built in order to make that happen. Now, as soon as you do that, let's imagine you bring that capability. You're going to get buy-in from the user who says, yes, this is generating value. You get the buy-in from a sponsor because he can consolidate the software landscape, needs fewer tools to get data access, and so on. So wonderful. You can demonstrate an ROI. People are happy. Now, you show that to a user, and the user sees a chromatogram. And he says, wow, wonderful. It's like a telescope when you have that first light event. So suddenly you have your Empower and your Agilent and your Chromeleon chromatogram on the same screen in the same app. It's quite powerful if you see that with your own data. But then you've got the scientist who looks at that chromatogram and you're so proud of your achievement, but that peak is wrong. So what's the scientist going to do? Well, the scientist will say, well, you've given me this beautiful solution, but my data is not as good as I need it. I need to reprocess it. So what does he need to do? Goes back to the lab PC, opens it up in his application that came with the instrument, and then reprocesses it, and then goes back, does the conversion, and so on. That is the status quo. That is so Stone Age. Because what we can do now, what we should be doing is, at the time where we are showing that data to the user needs to be able to act on it. And that's where the third level of maturity comes in, which is I can enable domain-specific processing outside and decoupled from vendor software. So that on the one hand, I may be able to do reprocessing, but the goal here is not to replace functionality that you've already got in the instrument software. The idea is to do stuff that is not possible yet, because, well, there is very little software that can work with the data from a bioreactor and the HPLC that you used on the sample you pulled on day 3. But here you can. And suddenly you are able to create a report that otherwise people would have had to cut and paste into a Word document template and spend a couple of hours to do so. If you have the data normalized, this is one of those processing steps that you can take that does that with a couple of mouse clicks. And for that, we've got this notion that we call pluggable data actions, where you can then hook in those best-of-breed processes and algorithms and workflows that make sense. And at that point, you can also call out to systems such as NiFi or NIME or Pipeline Pilot or so to do additional analytics on the data to enrich it. Okay, now we've got quite a capable infrastructure, set of capabilities deployed. Let's actually move a little bit further, because now the user says, oh yeah, this is cool, but it's a lot of mouse clicks, right? Remember, we are always value-centric, right? We need to show value to our end user, to our sponsors, and so on. So now the user says, yeah, this is kind of cool, but 1,000 mouse clicks each time. That's when the workflow automation bit comes into play, where I want to be able to automate the flow of that and make sure that it can happen with as little manual intervention as possible. So the scientist only needs to look at the stuff that they care about. So review by exception type workflows and things like that. And that's where that fourth level of maturity comes in. And then the fifth one, which is on the right, the data management aspect, is very clear. Now we have a very complete picture of the data and how it's being generated, and a beautiful level of data integrity. Now that data needs a home, and with traditional approaches, we know what the limitations are. So now today we are going towards data lake architectures. We have metadata tiers on top of that. We have ETL processes to populate these systems and enrich them with data from others. So that's sort of the fifth capability. And once we've done that, we have our data nicely lined up. And we can play the end game, which is what we have here on the right-hand side, with whether it's machine learning and AI, whether it's data mining, whether it's statistics. I typically don't know yet at the time I'm doing the experiment, right? I am generating the data with the hope to be able to reuse it again later, but depending on the question that I then have next year, I might be using any of those techniques or maybe yet another one. So that is sort of the idea. And so that's it from a capability perspective, what we feel can be done in order to assess the maturity. And now what is actually an interesting exercise is you can reflect on each of those pillars and say, well, yeah, we're already quite well set up, let's say, in the workflow automation or in data management or in visualization. And then you can look at, okay, what are the pieces where we have gaps? And that helps you assess what are the concrete steps that you can take in order to make progress, right? Because everyone wants data, but if we take a systematic approach, it's easier. So this is about the capabilities that I could deploy. Now, I also, and that has also been discussed, need to think about how that data is generated. And so my thought around data enablement is that, well, we need a way of generating that data efficiently. And that means we need to look at how our business processes work, right? And I believe we have a traditional notion of business process, and an analysis in the lab, to me, is also a business process, can be anything. Yeah? It can be also when you request a vacation from your boss and so on. Right? But you have a business process, and we have the tendency to make those business processes extremely efficient. That is sort of our goal, right? That is, yeah? But if we realize how such a process works is, we typically have a trigger. That means, okay, there is a reason why we are doing this. So whether we are in QC and we have a sample and we want to do a batch release, so this is what is triggering the analysis. You know? So that means we have a trigger question that we want answered. And now we are building an efficient machine to answer trigger questions, right? And we build LIM systems and LES to actually take us through the steps, and we take we make the data flow efficient so there's fewer manual work things and so on. So we're heavily optimizing the process execution itself, and our goal may be latency or throughput. Yeah? And we are all good at that, but we are also all guilty of that. Because we typically only capture those parts of the outcome to answer the trigger question. We are doing what we can to satisfy the immediate reason for the experiment, but any supporting data is dropped or lost in some silo, and I can't get to it anymore. So this is how we do our business processes on an everyday basis. Sound familiar? Yeah? Now, if we are so data hungry, then maybe we also need to think about how we data enable our business processes. And that starts with a simple realization that we don't have all the questions yet. That means we don't know yet what the things are that we may be able to learn from the experiment that we are doing today. But we have a willingness to learn from that. And we expect that we can learn from what we are doing, either by looking at the individual execution again later, or by looking at them in aggregate, seeing trends, being able to determine how good are we at this or at that, or what are we learning from. So there the idea is, let's capture as much of the underlying data as we can during the process or experiment execution, and then annotate it with sufficient metadata context so we can find it again later. It doesn't make sense to just drop it somewhere. We need to make sure that we also can find it again, and that's where enriching it with context is so important. And we aggregate the data enough so we can trace things back, according to the FAIR principle, for example. We don't necessarily need to ingest everything, but it's okay to aggregate, to drop some stuff, but if you have context and pointers to where it came from, you're already good. So don't fall for the temptation of actually taking everything. Go for the right level of granularity, but still have a reference to the rest. And for that, obviously, using open and standard formats helps us access that information again, because there is a cost to access. That is also an interesting characteristic of looking at it. So we've now looked at two aspects, right? We've looked at the capabilities that we can deploy, and this is looking at how we can think about the processes that lead to the generation of that data. And then, once we have put the two together, we can start thinking about explorative data analysis. So the secondary use of data. It's answering questions we didn't even know we had. And often that leads to discovering the unexpected. And I have a nice example for how those things then actually happen in practice. And I'll be happy to share that with you. So, okay, so how, let's assume that some of that stuff actually made sense. How do we actually deliver that? And let's start with the capability side. So, what we've done right now was we've looked at, okay, those are the capabilities that are there, and now let's think about how can we fill those with life. And at that point, it makes sense to look at, well, we agreed that standards are a good idea, but as we've also seen in previous conversations, it's, hey, let's look at the right tool to get a particular job done. So there is not one standard that does everything, but there are a few, when combined well, can generate the outcome that I'm looking for. So if I'm looking at going the last mile to the instrument and normalizing the data, well, that last mile can be done quite well using Sila or Sila 2, which was released last fall. If I'm looking at storing the data in a common format that is very accessible and easy to consume, Animal is a good candidate. And what we are then doing is we are sort of throwing into this mix a set of data converters for over 200, actually close to 300 instrument models right now, so that capability can be deployed. That's how we feel we can contribute to that ecosystem. Now, visualization obviously is about data, so there obviously only data standards would apply because you're not talking to an instrument at that point. So here Animal being able to be easily read on mobile devices as well and so on, and being digestible within web apps is obviously a good candidate. And here what we provide would be viewer technology that runs on Windows, on Mac, beautiful web experience, Android and iOS, so that capability can actually be deployed today. It's about delivering on the promise of standards, right? How do I actually make that tangible, and how do I make that happen? And then you can go through, right? For processing, obviously, that's more data-centric. And here we've got quite a few things in terms of peak finders and chemometrics and things that have been contributed by various ecosystem partners, which is quite nice. For workflow, there is BPMN, which is a beautiful standard that's already out there. We're not leveraging that enough yet in the life science world, I believe. And for data management, obviously, we have technologies such as NoSQL and data lake technology that we can put together. So today, we have all of the pieces that we need to deliver on those 5 pillars. And so, excuse me, that sounds pretty abstract. So let's make it more concrete, and let's see how we can apply those things in 2 typical use cases. So those are case studies of projects that people have actually implemented. And so the first one is about an LC-MS application for compound QC at a small molecule pharma organization. And this happened in Switzerland. So the first thing, first pillar, data aggregation and normalization. So this was a Waters instrument, mass links in this case. So they deployed a data converter for Waters mass links to animal. And they used the CELA interface for talking to the CDS and the balances that were involved at that point. Second piece, second pillar, visualization. They've deployed the desktop viewer application that we provided and the web piece, so that data that was produced by the instrument was ubiquitously available. And that rollout was fairly quick, and it's running on an AWS cloud, with the local client actually talking to the cloud backend at the time it needs to access the data. The next one, domain-specific processing. We have plugged in an existing set of chromatography and spectroscopy data analysis algorithms that we are then executing in an automated fashion, and the user has a way of configuring these processing steps. So it can say, okay, I need the following signals extracted out of my UV and my mass spec detectors. I need the following adducts to also be looked at. Then it goes and predicts the mass spectrum that needs to apply and so on, and goes from there. And then there is a way of consuming the output in a joint view, where I can see this was the microplate, and those were the ones where I got hits, and you've got the interactive analytical data on the screen as well. And then that workflow automation can be deployed to a server, so it happens automatically. And then you have a data management aspect where all of that goes into a data lake, and you can later on navigate either by compound or by other things in order to look for the stuff that was of interest. You can search by chemical structure, and so on. And then you get to data analytics, where we have this nice dashboarding capability, where we can go across experiments. And what was interesting, we did this presentation for the CIO of that particular company. He said, hey, what value are we getting out of standards? And then we looked at this data and we saw all of the samples that were in well A4 had a purity of 100% in every experiment. And that only became visible because we had a way of presenting that information, and that meant that something was really wrong about how that particular aspect of compound management was being done. And so this discovery alone already paid for the project probably multiple times over. And this is about discovering things, answering questions that we didn't even know we had yet. Yes, and then there are obviously capability. So if we're thinking about delivering on the promise of standards, I mean, we all know about animal, about how far it's along, and how easy it is to access. What I wanted to then basically look at was to understand how I then choose and assess the value and total cost of ownership of a standard that I go with. Because a standard itself is also not free. There is a standard needs business justification, and it must provide greater value than a proprietary approach, right? If proprietary is cheaper, I should be using that. So how hard is it to create such a standard file, or to read the file, how to store and manage the file, and so on? And then a good thing to do would be to imagine we have a file in a given format. What can a customer, what can a user actually do with that? and what is it going to cost them to do so. Yeah? Because then you have quantified the cost of access, and the cost of access is something that you are incurring every time you want to leverage the data. Yeah? So that is an interesting thing that you can actually quantify, and you can build models around where you can see, okay, what's the best approach for my use case? And then obviously it's an ecosystem game. With XML, you've got all kinds of tools, so it's readable by tools that were not even built for the lab. And that's kind of interesting here. So obviously ecosystem also means vendor adoption. So here are a couple of examples. SciEx is building their long-term archival strategy out of that. They did that together with 7 pharma companies. They also built their mobile experience. We helped them do that. On top of that, Labware, who is also here, who are also very willing to talk about this, good partner of ours, have native support for animal within the LIMS to take in data, even to visualize data in the LIMS UI. It's quite a fantastic proposition, and that's gaining a lot of traction in the market. If you're more into LabVantage, I understand there are people who do that too. It looks like this. There is a POC of the viewer integration in Thermo Science Cloud. And there is AAC Infotray who does that in their LIMS, or if you're a bit more into ICD, and then there's this. And IDBS has this capability as well. And Agilent, if you throw an animal file into OpenLab XT and you click it, this is what that looks like. Or if you buy from Merck a SpectroPoint proof, it also creates animal in the firmware. This is liquid handling and so on. So there's examples of an ecosystem that, if I have a data file, what am I able to do with it? There's an easy answer. There's lots. And that is, I think, a very promising thing. And if we now look at the lab informatics market distribution, we now have built-in capability of these types of features in over 42% of the total market, who only use the BSSN software components to do so, and obviously another few that do it without our help, which is fine. Frost and Sullivan thought as well that this is a cool idea, so they gave us this innovation award. And so looking back at the original question, can we deliver on the promise of standards and interoperability? I think we can answer yes to that. Yeah? And so I stole this quote from Barack Obama, who we are all very sorry that he's no longer in charge. Yes, we can deliver on the promise, and we can count on vendors to supply commodity off-the-shelf components of an ecosystem. And yes, there is value that can be captured that way. So that's my food for thought for how you can maybe deploy and leverage those things for yourselves. Thank you.